Hey folks, Mr. Dell here. We are looking at a scatter plot problem, dealing with a set of data, and from that making some predictions and looking to find the line of best fit, and all that good stuff. So let's start off. This is just so we know where this is coming from. This is course 3 of CPM, and this is section, let's see, it's section 7.3.2. Specifically number 103, 7-103. So let's read it and get into it. Marissa's older sister was discussing purchasing a car with her summer job earnings. Marissa collected data from her friends at her job. So here's the data she collected. Looks like we got a table here. Age of car and in years, and then the fuel efficiency, miles per gallon, for each of those cars. So it says in part A, Marissa would like to know the typical age of her friend's cars. What kind of graphical display would she use? So if I'm looking at the typical age, looking to find the typical age of her friend's cars, that would be wanting to see how many of the students of her friends, I should say, had cars between, say, 0 and 3 years old, 4 to 6 years old. So you're looking at if you're looking at the number of, and you want to talk about maybe even the mean, you can either do a box plot, could work. So we could look at as the median. What's the median, the middle of the range, or a histogram, and a histogram is going to give you that the data as far as number of. It'll give us that bar graph, if you will, that histogram that gives us how many cars are ages 0 to 3, how many cars are ages 4 to 6, how many cars are ages 7 to 10, and then you can build that histogram. So on this question here, I would probably answer it histogram. You could also justify a box plot as well. B, Marissa wants to convince her dad that newer cars are more fuel efficient. What kind of graph would Marissa make to convince her dad? So in this case, if we're trying to show the relationship between the age of car and the fuel efficiency, and then with that be able to show that the newer the car, the better the fuel efficiency, that's looking at the relationship of these two pieces of data. To determine if there's a relationship and show if it's either positive or negative, you would want to use a scatter plot. So we're going to use a scatter plot to look at that data. A scatter plot. So it says, part C, make a scatter plot of the data. So scatter plot, remember we need to decide who's our independent and dependent variable, who is my X and my Y on my axes. So I'm going to draw my axes here, and then we'll look at the data and label and figure that out. So I'm going to draw just the first quadrant looks like I'm going to use, right? All we need is the first quadrant because the data we're dealing with is all positive data. Age is positive numbers. Fuel efficiency is positive numbers. So age of car is my years, and that would be my independent variable, right? So the age is the independent, because then the fuel efficiency, we're determining whether that's dependent upon the age. We want to determine whether the fuel efficiency is dependent upon the age. So that's our dependent. So this is our X, this is our Y. A good rule of thumb too is a lot of times your time factor, in this case years is my time, is your X axis. It's your independent variable. So this is going to be our age, and I'm going to label that in years. Okay, and then this is going to be my fuel efficiency. And that's miles per gallon. Okay, so we got to decide my scaling. So if I look at my years, I can see it's very safe to say that my years, I'm going to make my scaling by ones, because I've just got to go up to 10 is right now my data has my list majority. And then this looks like I'm going to do by, I've got my lowest piece of data at looks like 27, and my highest piece of data is at 40. So I want to make sure I get to that 2740, but then I also want to make sure I have enough detail between 2740. So maybe I'm going to go by threes. Let's see if I have enough space here. I might have needed to make my graph bigger. So let's go, if we said 3, 6, 9, 12, 15. So, and then I would need 5 to take me up to 45. Yeah, we could do that. So let's go by threes. So this will be 3, 6, 9, 12, 15, 18, 21, 24. Right? See that so far? And 27, 30, 33, 36, 39, 42, 45. Okay, so there we go. And then I'm saying these are going by ones. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. Okay. So now let's just graph my data. So this is now, once I have my scaling, my X and my Y axes, now I go to my data and I graph it. So I'm going to see how I can do this where you can still see. I'm going to be bumping back and forth, I think. Okay. Or actually, let me just raise up the camera so you can see more of what I'm doing here. Okay. All right. So we're going to start with 934. 933 is there. So we're going to go 934 right above it. And we've got 230. So 230 is right here. 530. 530. 135. There. 434. 10, 28, and 9, 27, and 3, 40, right there, and 8, 29. So right about there. So there's my data. So now let's look through these questions and determine what they want us to do. So we've got the scatter plot. That was part C. So part D is fully describe the association. So if we think about our association, I can see that there's this downhill trend, right? So that would be a negative association. So my association, I would say, is negative. And then we want to say, is it a weak association, or is it a moderate, or is it a strong association? Well, strong, remember, would be the data would be very close together and almost look quite linear. But in this case, it is slightly going downhill, and the data is a little bit spread apart. So I'm going to say this is a moderate association, right? So it's a moderate negative association. Okay, so that's how I'm describing our association. Then it wants us to draw a line of best fit on the data and find the equation of the line of best fit. So if I'm going to draw a line of best fit and find its equation, I'm going to try to find 2 points I can go through so I can then find a good slope. And remember, when you're looking for line of best fit, you kind of want to make sure that your points you have about the same amount of points above and below with distance equal distance, right? So to the line. So a very similar distance to the line. So if I picked this point and this point, I'd have 1, 2, 3 above. That one's almost on it. 3 below. So that might be a good set, is using that point and that point. That might look good there. So I'm going to do that. You could probably use this one and get away with it as well, because then you'd have 4 above, 3 below, and it's very close. So it's either one. In fact, I'm going to do that because that's right on a nice lattice point. So I'm going to use that one. So here's my line of best fit that I'm choosing. So we can see that line is negative. It's downhill. So it is a negative association. Now we've got to find the equation of that line. To find the equation of a line, a couple things, right? So you know an equation of a line is y equals mx plus b. Your m is your slope, right? And your b is your y-intercept. So those are the things I need to find with this line. Remember, slope is what? Slope is that change in Y, and I use delta Y as an abbreviation, over change in X, and I would use delta X for that, right? So change in Y, change in X. That's what I need to do. So I use a slope triangle. I'm going to draw my slope triangle from that point to this point because that's what I went through. So this right there is that change in Y. How do I determine that change in Y? Well, what is the Y from going from here to here? Well, that point, what was that point? That point was the 434. And then this point here is, what's this one? That one is 927. So if I'm going from, my Y is this, and this is my Y, so I'm going from 34 to 27. So how do I figure out? I take 34 minus 27, and I get 7. So my change in Y is 7. And then this would be my change in X. So I know what I started at 4, I go to 9, so that change in X is 9 minus 4, which is 5. Right? So that's how you find your slope. So slope for this problem, I'm going to write it down here now. Slope for this problem is the change in Y, 7, over the change in X, 5. So 7 over 5, that's my slope. So that's this part, that's the M. So far I know my equation is going to be Y is equal to 7 over 5X. Now I've got to figure out my B. My B, remember, is Y-intercept. So this, because we're drawing this estimated line of best fit, you're going to just estimate where does that cross the y-axis. So there's 39, there's 42. You could say 40, maybe even 41. I'm gonna go with 40 because it looks closer to the 39. So I'm going to say plus 40. So there's my equation of that line of best fit. Okay. Now, part F wants us to use the equation to predict what the correct fuel efficiency for a 7-year-old car should be. So remember, on my equation though, in this equation that I have, the Y represents what? The Y represents miles per gallon. That's my fuel efficiency. The X represents the age of the car, right? So I need to do what? I need to find out what is the fuel efficiency. So what is the miles per gallon for a 7-year car? So for F, I'm going to plug in, I'm going to say, what is Y? What is my fuel efficiency when I have a 7-year car? So I plug 7 into the X and do the math there, right? This is where it's quite all right to deal with a calculator if you're having to come up with an approximate answer on anything. So I'm gonna, on my calculator, just figure this one out because I've got, really, that's 49 over 5. Well, I don't need a calculator. I can do this one. So that's 49 over 5, which is 49 over 5 is 9 and 4/5, and 9 and 4/5 plus 40 would equal 49 and 4/5. So almost 50. So our fuel efficiency, so for F, we would say a 7-year-old car should, oh, that doesn't make sense because that looks 30. Wait, I did something wrong here on my math. Oh my goodness. Let me back up. See, we all can make mistakes here. I had my equation wrong, don't I? Because here's what I just did. It's good to learn from mistakes. I went ahead and did my math with this, and then I determined, I said, wait, 49, that doesn't make sense because 49 is way up here. Okay, I got to go back to the equation. You probably caught this a long time ago. The equation should be a negative 7/5 x. The slope is negative 7/5. Why? Because it's a downhill line. It's decreasing. It's decreasing. And it took me a little bit to catch that, and I finally caught it. So I'm gonna just redo my math because that's not so bad. That's going to be negative 7/5 times 7, which is a negative 49, which is negative 4 and 4/5, which, cross that out. So I'm going to have to subtract 40 minus that. So it's going to give me 31. So that equals 31 and 1. Oops. 30 and 1/5. 30 and 1/5. 49 minus 9 and 4/5 is 30 and 1/5. So a 7-year-old car should get, you could say, approximately 30 and 1/5 miles per gallon based on the math we did using our equation. All right, do I have one more I think I need to look at? One more question. It says interpret the slope and y-intercept in the situation. So my slope and y-intercept. What is my slope? My slope represents what? My unit rate of miles per gallon for every year. So my slope represents miles per, keep wanting to do that, miles per gallon for every year. So it's losing, right? Losing 2 2/5 miles per gallon every year. So that's what I'm going to write for G. My slope is a loss of 2 2/5 miles per gallon per year. That's what that means. That's what the interpretation of the slope is. What is this interpretation of the y-intercept? Well, the y-intercept, you're looking at 0, meaning the age of car is 0 and it's miles per gallon. So we're saying, the y-intercept, what does it mean? Means that a brand new car, because it would have an age of 0, right? A brand new car, age of 0, should get, and what did we determine? Our slope here was 40, should get 40 miles per gallon. So that's what the y-intercept is interpreted as. All right, folks, I hope that helps.